without further ado, let's talk a little bit about the energy revolution. And I'd like to frame a question for everybody here, which is, imagine what your organization could do if portable energy was essentially free. And if we just think about that for a moment, it's a pretty big concept, but it's actually something that is on the horizon for a lot of organizations that are thinking about portable energy or the applications thereof. When we look at the reduction in lithium-ion battery prices as a function of energy density over just a decade, it has dropped nearly ninefold, or 872%, from where it used to sit at 2010. And this curve will continue to drop at a precipitous level as we continue to move in the 2020s. We are finding new and novel ways to compress that energy density within the lithium-ion context. The challenge, though, is that this is not free energy in the same sense as we might want to think about this. And the reason is that there are indirect costs of lithium-ion batteries. Some of the cathode materials that are being leveraged in this, cobalt and nickel, are rare and they're hard to extract from the earth, which can lead to conflicts and other costly measures around procuring these material types. The other side of the equation, the lithium side, is that it is actually easier to mine. However, the byproducts of that mining process actually can poison water supplies and have been known to. And that is a tremendous environmental impact for the process where we are continually using more and more lithium-ion batteries. And then on the other side of the equation, once you have these lithium-ion batteries, you need to dispose of them in a meaningful way. This is challenging because lithium is a combustible, so if it's exposed to air, it can cause explosions, and so it's costly and dangerous to kind of recycle and dispose of these materials. You might ask, well, that's the way the world is, and maybe we'll just go with the lowest price point because there may not be a strong motivator to change, but I would say there is. And what we've been seeing is that sustainable investment over the last 7 years has been doubling in size. So big organizations, large investors to the tune of billions of dollars are withdrawing funds from non-sustainably driven companies and investing into those that are. And now we're looking at a $30 trillion plus investment market for sustainable investments. So if you're thinking about your organization, you might be faced with a near-term challenge that might fall on you unexpectedly, where you're asked to switch out all of your lithium-ion battery products because from the investor relations perspective, that is what is being asked for. So let's talk a little bit about what some of these technology types are and why they're important in the context of perhaps thinking from an environmental standpoint, a performance standpoint, and a safety standpoint as well. So lithium sulfur batteries have actually been hailed as kind of the next big step in battery technology, which actually will outperform lithium-ion battery while also being environmentally sustainable. I will say that in that hype cycle curve, there's the expectation that it will do better, but right now it doesn't actually perform over the life cycle of that battery at the moment. But they're continuing to work towards this, and this is something that if you're in that space, you might want to keep an eye on. IBM has created what they call a no-metal battery based out of entirely based on components that are extracted from seawater. And so this is something that they're hoping to move into the front and center of the space, hopefully within the next few years. And this would be a big game changer, again, kind of thinking a little bit about that environmental spin on how to remove ourselves from the entropy associated with lithium-ion batteries. There's a group out of Adelaide that has now partnered with the Chinese battery manufacturer on their patented work that has created a completely non-toxic zinc and manganese battery, as well as a non-combustible aqueous electrolyte. That's great. And that they have also said that this is going to be something where the new battery will produce energy at less than $10 per kilowatt hour compared to that 300 point or even the 132 that we were looking at a few slides ago. So again, you can actually have higher performance while being safe and environmentally focused. These things don't have to be mutually exclusive. On the safety and performance side of the equation, there are quite a few new concepts within the battery regime that are going to make the idea of energy different than it used to be. They don't have to fit in cylinders. They don't have to fit in little packs. They could be anything you want them to be. Gen X is a perfect example of this, a foldable battery, like paper but tough. It can be folded nearly 200,000 times before losing any performance. So it changes the way we think about what energy can do for us. And a new battery coming out of Japan that is entirely produced out of carbon-based materials, which is sustainable, environmentally friendly. They also assert that this technology will produce 20 times faster charging than lithium-ion batteries and will last up to 3,000 charge cycles with lower chance or no chance of explosion or fire. So just thinking about these concepts as a whole hopefully gives you some concept in terms of where you might put yourself if you're thinking about the next application. And the last one is for the healthcare folks in the group. I don't know if you've heard or talked about this, but there's this new technology called a Rectana that's come out of MIT about a year ago. It can pull power from Wi-Fi signals in the air, so there's no battery, and it has enough power to sufficiently run silicon chips. So this is hailed as possibly one of the biggest advances in battery technology because it can be used within the body without killing your patient. As you can see that quote at the bottom there, you don't want batteries in your patient because if they leak lithium, that's bad for the patient. So this is, again, one of those concepts where I think if you're thinking about what to do in your space, this is one of those situations where you should investigate this concept perhaps, or speak with somebody that knows more about it. And so when we're talking about these 6 technology types, it's difficult to digest and understand the capacity and what portable energy can do. So I always like to kind of talk about vision, and this is actually a real video, like a real test flight of a company called Lilium. They're a German-based company, and they're doing eVTOL. This is a completely electric-driven vehicle that has a 60-minute flight time that can zip around at 300 kilometers an hour, 4 passengers and a pilot, and it's relatively low noise. They are currently being certified within Europe and by the FAA in the United States, so it wouldn't be shocking to see them on the market within a few years. This is, I think, where you can take where where the technology actually meets traction in terms of we have reached a point where the concepts around energy and energy density have reached parity with some of the high-end applications. And this isn't the only eVTOL or the only company working on electric flights. Airbus is also committed to working on that as well. So through this application, I think what we're going to be talking about, this masterclass is, if you were a hypothetical company, how could you take some of the concepts we just talked about? And we're going to kind of walk through that as a function of 3 macro areas. So if I was a healthcare company and I just heard that, I might say, okay, well, now we have the way with the Rectana to perhaps do a novel wearable for immune response. And we'll see how that evolves as we continue to move forward. If you're in the manufacturing space, I would say, there's a lot of hard to reach locations. Maybe we should reinvestigate or investigate drones for security, but also plant inspection purposes on a more routine basis. And if I was in the CPG and or food and bev space, I might ask and say, well, maybe there's a way to create high impact packaging, integrating lights or LEDs or something that's going to make us stand out from the crowd and differentiate ourselves from our competitors across something that has approximately the same margins because of the cost point of that energy now. So as we move through all 5, we're going to kind of revisit these three kind of clusters.